Thanks, Chris. Thanks for the introduction. So we have this quantum finance panel where we have some interesting people talking to you, Carlos from BBVA and Jeffrey from Chicago Quantum. We as Amro are doing our own quantum projects together with QSOF, as Harry Burma mentioned. But there's more people doing that, and they have some very interesting things that they can give to you. I would also ask the audience to take a look on the right side of the Q&A, where we're going to try to also put some polls into that, because it's also interesting for us to know what you are thinking. We'll start with some first introductions. Later on, Jeffrey, but we'll start with Carlos. Carlos, the floor is yours.
Thanks a lot, Dimitri. It is a pleasure to be here sharing part of our experience in what we call the BBVA Quantum Ready Journey, where we are also now creating the internal quantum mindset. Some of the learnings that we have, I think it's better to explain our history in a brief way. We started more than 2.5 years ago, understanding that the potential breakthrough of quantum could be create a great impact in finance. So we started 3 months of what we call a scouting period, where we try to understand the state of the art, the different actors, and the reality behind the hype. So we conclude that there was a probability that in less than 5 years, quantum technologies in different ways could create a relevant impact. And of course, in more than 5 years, it's going to be a huge impact. So we start the next stage that we call discovery phase. In this stage, one of our challenges was to start creating our quantum core team, start hiring quantum researchers, and attract these talents is not so easy sometimes. So we combine internal talent with people with deep knowledge about financial complex problems like asset management, corporate investment banking, with new talent that we combine. Also what we call now this quantum core team. So in this discovery phase, we started to analyze and creating in an iterative way our prioritization framework to understand what could be the problems with more high potential impact. And we make this in conversation with different teams. We start making evangelization internally, so we could start listing different potential problems and applying our first interaction of our prioritization mechanism. So after 6 months of this discovery phase, we ended with 10 new potential problems where we could start making proof of concept. In the meanwhile, also we start connecting with the ecosystem to try to solve with different partners around the globe to try to start executing this experiment. So we connect with the Spanish research centers, we connect with companies like Fujitsu, Zapata, Multiverse, and also with other big digital giants and consulting companies like Accenture. And we execute in the last 1 year 6 proof of concept that we published some good results, mainly in portfolio optimization, but also we tested other things like Monte Carlo, also quantum Monte Carlo algorithms. So now we are in the second discovery phase where we are finding new challenges. That is okay, we discover some things, we need to test in production. So now we are trying to plan our end-to-end project, how complex could be to put some quantum hybrid algorithms in production. So for this, we are connecting with different architecture teams, with security. So we are trying to move this to another level. The goals of this, of course, we have as a research team, we have ambitious goal to make impact in less than 1 year, but also we are pragmatic and we know that this could be difficult or impossible, but it's part of our journey to start evangelizing with real potential use cases to the rest of the organization. And now we are in this phase, also trying to attract new talent, trying to also evangelize and get to new internal talent, because we have a lot of physicists and mathematicians internal in the organization with a lot of interest in quantum. Meanwhile, we are continuing connecting with the ecosystem and making new problems. So we are now super passionate about the future, and we have some challenges about what is going to be the stack, how to start connecting this from lab. This is one of the main challenges, continue researching. Meanwhile, the thing that we think that could make real impact, we could start moving step by step as a regulated company to potential production in the future. And this is the brief story to start.
Okay, thanks, Carlos. Carlos, great work. I'm really excited to see what comes out of that later on. Jeff, over to you. You prepared some slides. I think we can put them out, and you know how to click. So can you tell us a little bit about Chicago Quantum and what things you're doing lately?
Absolutely. Thank you so much. And I really appreciate the opportunity to speak to the conference and to talk a little bit about the work that we're doing. So Chicago Quantum was launched in December of 2018 as a company that evangelizes and brings quantum computing to enterprise corporate clients. And so our vision is to be a consulting company that also provides applications. And actually right now we have a live quantum computing application that banks, insurance companies, asset managers purchase and use it to pick stocks. So today we use the D-Wave system and we pick, let's say, 134 stock portfolios or much smaller portfolios that are a minimum variance but enhanced expected return portfolios, and we bring those to market. And so we're very excited to have found an application. So I want to talk a little bit about that. And so we are a consulting firm. We have 4 PhDs. We have 4 with advanced degrees that are not PhDs. We go from physics, economics, math, just general IT and computer science. We focus on the commercial client base, although we can do government contracts. It's amazing, how did we develop a product? Clients would ask us, so can you show us how it really works? And until we started putting fingers on keys and building code, we couldn't really talk about it. The first thing we did was we built a proprietary algorithm, a quantum algorithm called a Chicago Quantum Net Score that applies a Sharpe ratio, but it runs on a quantum computer. And we have experience, in these areas. And so I'm just showing a little bit of the website. What's interesting is, what does it mean to have a quantum program or application for clients? And so I'm showing you the 3 quantum offerings that we have on the website. One of them is a reduced volatility, enhanced return portfolio. So this is very similar to what Vanguard, BlackRock do, where we'll search 64 stocks. And you can't quite do this brute force, but you can use Monte Carlo, genetic algorithms, simulated bifurcators, simulated annealers to do this. But a quantum computer gives you a great answer as well. It's up to 64 stocks, so it runs on D-Wave, the Chimera system. But over to the top right, you see we have an enhanced return portfolio with over 3,000 stocks. That's a search space of 10 to the 954th power. That's an enormous search space. And we're able to use all these classical algorithms, but still run it on the new D-Wave, the Advantage. And then we also help clients with custom portfolio, algorithm development to climb what we call the sophistication curve. And I thought for this panel, people would be interested, what is it like to use the D-Wave system? So we focus right now on quantum annealing. We're also heavy into research on quantum walks on graphs. And so we use it in our R&D efforts. So we pick stocks, we basically send our QUBO or our matrix to the D-Wave quantum computer, and it will come back much, much better than average. It is a really effective solver for any type of problem that is a QUBO. So it's a binary problem. So here's the math. On a 2000 Q, we can run 64 stocks. Those are 64 fully connected vertices or clicks. The Advantage we can run 134 stocks. So we're more than double on the new system. And we are racing now to get a paper out to document this. We've run as many as 138 stocks. So when you think about it, right, the new D-Wave that came out in September allows us to more than double the number of fully connected vertices. And the only challenge we have now is it's so busy that the wait time to use that system is about 10 minutes. Whereas on the 2000 Q, it's near instantaneous. And so I just want to close with one thought. So what does it look like to do quantum algorithms? It's just never enough. And so right now we're doing work on the higher moments of stock portfolios, which is skewness and kurtosis, which moves us from the buy and hold strategies to the option trading strategies. And so we will be coming back to you with enhancements in the higher moments. So thanks, Dimitri, for the chance to present.
You're very welcome, and thank you for your contribution. I think you raised an interesting topic, and I just want to see if we can have the audience also into this. So people, if you can just look at your right side with the Q&A and the polls. I'm hoping that there's a poll out, so we can also test if this system is working or not. Because you guys you mentioned the D-Wave, Carlos, I believe you also mentioned the annealing part. That's part of your exploration in the fields of what kind of hardware will be used. While we're waiting for the polls results from the audience to come in, Carlos, what would you say is the first applicable hardware you would use? Hybrid, annealing, niche machines? What's your opinion on that?
In our case, we tried to be quantum agnostic, in quantum backend agnostic, and we tested, I think, a lot of different backends. The idea is to try to also have a benchmarking. In my opinion, the first real application with impact could be with quantum-inspired algorithms running over tensor network. It's a good architecture that is multi-matrix dimensional, could solve multi-matrix dimensional problems with the concept of quantum algorithms. Data annealer like Fujitsu is working really well and has a lot of potential. And also quantum annealer like D-Wave is something that you can start applying and creating some advantage in quantum optimization. After that, it's difficult to predict what is going to happen with the NICs or other quantum general computers, but I think that we are living something similar like a Manhattan global project where public institutions, governments, and private companies is investing hard. So I think that probably we're going to see capacity to run in quantum general computers or gates with solving real problems soon. I don't know if it's going to be 2 years, 5 years, but soon.
Okay, thanks, Jeff. So you mentioned D-Wave, that's been used extensively probably with your company, but is the D-Wave the only thing that you're going to use? Or do you have any other areas that you're exploring at the moment?
So we do. So the D-Wave, I mean, as a start, just provides the type of scale that we needed in order to make it go from a toy problem to a production size problem. We are looking at quantum walks on graphs, which can run either classically or on a gate-based computer in order to maybe have information travel a little faster and maybe provide us some speed ups. Eventually we'll move to universal, but for right now, it's just not large enough. And then we have had conversations with Atos, with the QLM, and Fujitsu with the digital annealer. And we think of it as just another solver, just another kind of horse pulling the sled to pick stocks for our clients.
Okay, so I'm closing the poll now. I think if you look at the answers, I think the audience also agree with you that annealing will be one of the first. And then a good second one are the NIST machines. So Carlos, do you have any plans or are already executing projects in the fields of NIST machines?
Yes, you can see our results in internet. If you look for BBVA quantum, we publish a different result, some with papers, academic papers or scientific papers, sorry, and other trying to show our result. So as I was saying, this is a long journey that is complex to be prepared, that is not going to be easy to catch up in less than one or 2 years. So our bet is to start testing different backends. Meanwhile, we are developing and building our algorithms, understanding the problems that we could solve, what is the impact that we want to try to achieve, and also creating internal talent. That is one of the more complex parts. The problems, I think, is clear, the short term for quantum, 2, 3, 4 years, optimization, simulation. And there are a high number of problems and a lot of potential benefits for your P&L around optimization and simulation problems.
Okay, Jeff, you wanted to add anything to that?
No, I'm good. Let's keep going to the next. I was hoping we would talk about energy efficiency. That's what I was looking for.
Energy efficiency. Well, that's another topic, but since you raised it, so you probably want to, let's talk about energy efficiency. You know, there's some articles out there on the internet you can search for that say that quantum computers will be more energy efficient and will lower the energy footprint. Is that so? Is that really what we can expect, Jeff? What do you say?
So I think yes. And so not only did we early on provide an article in Medium that talked about comparing quantum computers with classical, but if you think of it this way, a quantum computer, which could be shared by many companies or could really drive a lot of research for one company, has the power footprint of a storage area network. And so it's not a very large device. Maybe it's 15 kilowatts. The actual chip itself runs, maybe 1 watt. So what happens is if we can put in place high capacity, let's say quantum annealing systems, have them on the cloud, you're replacing potentially thousands of servers. And so if you think of a supercomputing environment, you need a whole power plant to run one of those. If you think of a quantum computer, it's a small PDU. And so what I would say is, as we scale up quantum computing, if we could offload the work from classical, we can offload gigahertz of power off the grid.
There is an interesting angle building over what you say, Jeffrey. For me, there are 3 different also complementary angles. One is that the classical computer, as we know, is going to maybe reaching the limit. And also we are adding more complexity because we want to solve more complex problem, combinatorial problem, and also we have more data. So the energy consumption is going to high really, really fast. And for this quantum computing, quantum annealers could start creating or solve this high complex problem with less energy consumption. This is one promise. The second promise for me that probably is more interesting is that how quantum computer, this optimization, could start solving one of our big problems in the society, like sustainability, for example, carbon intensity emission, scheduling in logistics. That could be a great way to reduce emission and to try to solve this kind of problem. So if you combine these 2 parts, how we are going to reduce computing consumption, energy consumption, plus how quantum computers and quantum algorithms and other quantum sensing could start solving these high complex problems for the society, is a really good tools to have now in this challenging decade.
Yeah, I want to build on that. So just like the ERP of the 1990s and 2000s, if quantum computers can help us optimize business challenges better, whether it's transportation, logistics, whether it's chemistry, battery production, ammonia production, quantum computing can unlock the next wave of corporate productivity. And that's one of the reasons why we got into quantum computing in the first place.
And I agree with that. And a lot of this enterprise productivity is related to supply finance, related to supply chain, and how to have better risk scoring and less counterparty risk. And one more time, optimization, simulation are tools that could create a lot of efficiencies.
Okay, thanks. It's so I'm facing the same kind of things. ABN AMRO, sustainability, banks, big topics. So should be easy to convince management, right? Truth is, it's a little bit harder than that. So, Carlos, so what did you do to convince management to move forward with these quantum projects? Are there any results, concrete deliverables that you put on the plate within a certain time frame, for instance?
The first is to try to understand and explain what is the level of energy, in this case, investment plus talent that are in this space. When you saw the number of, or the amount of money, the budget that governments are putting on this, you start understanding that probably something big is going to happen. Combining with the private investment is a really good sign. After that, you need to show tangibility, potential tangibility. What are the problems and what are the part of the P&L that you are going to be able to grow or to create efficiencies? And of course, the intangible thing is that it's only the first part of the peak of the iceberg, because quantum, the main capacity is that the thing that we cannot understand now. But continue and elaborating a bit more, I think that you need to offer a clear, and for us super important, a clear prioritization framework, because this explains two parts. One is you understand the problem that you want to solve and the impact that this problem could create. And second, you understand the algorithms that could solve or make impact in this problem with the feasibility and the horizon to start applying these algorithms in production. Of course, we used to have different projections and different scenarios. One, quantum winter. Nothing is going to evolve from this moment in 10 years. Quantum and medium progress. We are going to continue creating more capacity, more quantum volume, and this is going to be something like this. And also we have the third, that is our quantum breakthrough. Something is going to happen in some lab that is going to accelerate in exponential way the ecosystem. And we check this with different signal and KPIs every 6 months, because as a research team, it's easy to be a dreamer, but we need to be pragmatic. And this is working.
Nice, Jeff. So you're working as a consulting company towards different organizations. So you probably have this huge pile of arguments you bring to the table when talking to management, right? Can you elaborate a little bit on that?
Absolutely. So it all comes down to one argument. What's the value proposition? What's the net present value? What's the art of the possible? And so if we talk to a client and we want to talk about quantum science, they're not interested. If we talk about security, they're very interested because they understand the risk or the insurance potential of being able to secure a network. But for us, as long as we stick to something that has value, it's going to make sense. So I was once asked a question, what would it take for a bank to buy a $15 million 3-year quantum contract? And the answer is a couple of basis points. So the largest money management funds, if they could add 5 basis points of return, could pay for a whole quantum computer. So the question isn't, can I get quantum advantage because the quantum computer is better than any computer in the world? No. The question is, can the quantum computer make this company better than they were? So at the end of the day, I haven't had a single client really want to talk about the technology. We've got the physicists. We're ready. We could talk math all day, and they just say, just give me the business case. Where's the money here? So what I would say, if you're a student and you're looking at quantum, or you're a client and you're thinking about quantum, figure out the problem which would drive your stock price up, or think about a problem that would help drive, let's say, renewable energy consumption in your community or clean water. And that's what you focus on. And then quantum is just, like we say, another horse in the race, another solver to solve a problem.
Okay, thanks, Jeff. Great answer. So some questions from the audience. Carlos, this is one for you. How many people are in your quantum computing team, and what kind of talents do you have working on that?
Well, we have been working in Agile in our organization for more than 4 years, so the answer is dynamic. It depends. We have a core team with a small number of researchers and also people with deep knowledge. It's like an onion, or if you can say the quantum analogy, it's like a molecule. And after that, we have a quantum hub that is connection with other departments in the organization, from business to security, to architecture, to legal. And also we have our partners, and also the research center, public and private, startups and big organizations. So it depends on the quarter, and also depend on the quarter and dynamic.
Okay, so last question, Jeff, for you. Have you followed up on how the portfolios have performed lately?
So we have. So what's interesting is when the markets are going up, the portfolios tend to do very well, because and we publish this on Medium, and we have tools to do this. When the market's going down, these portfolios still have that exposure to market. And so there's a little reduced volatility, but you know, no one makes money when the markets go down. But I would say, yes, we track it. And for clients, we've had clients make investments based on these portfolios. In fact, I myself have invested in one of the results and made a significant return very quickly.
Interesting. Thanks, guys. I think we had some great questions, polls, and some excellent answers. Unfortunately, we're out of time. So I'd like to thank you for taking the time to do this panel. It was a pleasure to moderate you guys. And looking forward to new results from your projects. And until then, until next time. Thank you.
Thanks so much.